In this video, we will see about the preparation of colloids. First method, that is chemical method. Colloidal dispersions can be prepared by chemical reaction leading to the formations of molecules by double decomposition, oxidation or reduction or hydrolysis. The molecules then aggregate leading to the formation of salt. Let us see one example. AS2O3 plus 3 times of H2S by double decomposition you will get AS2S3 salt plus H2O. Like this one, SO2 plus 2 times of H2S under oxidation you will get 3 times of S salt plus H2O. Like this one, 2 times of AuCl3 plus 3 times of HCHO plus 3 times of H2O. Then undergo reduction, then you will get gold salt. That is 2 times of AU plus 3 times of ICOH plus 6 times of ICl. Again, if you take ferric chloride and add it in water, then undergo hydrolysis, then you will get ferric hydroxide salt along with 3 times of ICl. This is what the preparation. So, in the chemical preparation, as we have discussed here, is that a chemical is added to the substance which we need to prepare your salt, and then a chemical reactions take place. The chemical reaction may be the double decomposition reactions, or maybe oxidation or reduction reactions, or maybe hydrolysis reaction. And during this chemical reaction, there is a formation of new molecules. These molecules then combine together to get an aggregate which leads to the salt again. This is what about the chemical method. Now we will see the electrical disintegration or Briggs arc method. So which the picture is here. So here we need to add two electrolyte to the dispersion medium. The dispersion medium is kept into the ice bath. When you struck, then the two electrodes, then an electric current will produce, means that an electric spark will produce. This spark give heated and the metal start vaporizing, and this vaporization of the metals again condense to form the colloidal size. So this is what we have done in the Briggs arc method. So let us read it out again. In this process, the process involved dispersion as well as condensation. Means that first step is dispersion, next step is condensation. So through this method we can prepare gold salt, silver salt, platinum salt. So in this method the electrical arc is struck between the electrodes of the metal immersed in the dispersion medium. The intense heat produced vaporize the metal, which then condense to form the particles of colloidal size. Next is baptization. Baptization may be defined as the process of converting a precipitate into colloid. The process of converting a precipitate into colloidal solution by shaking it with a dispersion medium in presence of a small amount of electrolyte. So in a particular medium you added your precipitate and added a small amount of the electrolyte, then shake well. Then if you get the colloids from that precipitate, then it is called as a baptization. So in the baptization, the electrolyte which we added is called as a baptizing agent. So during baptization, the precipitate absorbs one of the ions from the electrolyte on its surface. This absorption of ions causes the development of the positive or negative charge on the precipitate, which ultimately breaking down into a smaller particle in the size of colloids. So like this one, we prepare the colloids by the process of baptization. Now, the process used for reducing the amount of impurities to a required minimum is known as a Purification of colloid. So in case of purification of colloid, we need to remove the impurities. Impurities means here your electrolyte is an impurities. So if you start removing the impurities up to a certain limit, that is which we call as a minimum limit, then it is called as a purification of colloidal solutions. The purification of colloidal solution is carried out by the following methods. First method is your dialysis. Dialysis is the process. So here is the picture of dialysis. So dialysis is the process of removing a dissolved substance from a colloidal solution by means of diffusion through a suitable membranes. So the process of diffusion is used in case of dialysis. So we can ask, what is the principle used in dialysis? Your answer is diffusion. So for that dialysis, we use an apparatus. That apparatus is called as a dialyzer. So a bag of suitable membranes containing the colloidal solution is suspended in a vessel through which fresh water is continuously flowing. So if you flow the fresh water on the vessels where the bag is hung along with the colloidal particles. During the time, the ions present in the electrolyte are dissolved in water, and thereby they start diffuse through the membranes towards the outer water outlets, and only the colloidal solutions remains in the bag. So this process is used in case of dialysis. Now next process is of your electrodialysis. That means in the dialysis process is done under the presence of electrical field. As electrical field increase, the process of dialysis. During this process, colloidal solution is placed in a bag of a suitable membrane, while pure water is taken outside. Electrodes are fitted in the compartment. The ions present in the colloidal solutions migrate out to the opposite charge particles. So if you put that electrolyte into the solutions, then automatically colloidal particles are of charges, so they will be separate out towards the opposite charged electrodes, and this process is called as a electrodialysis. Through electrodialysis we can purify colloids. Another one is ultrafiltrations. That means here ultrafiltration means you have done filtration process, but in the filtration we didn't use simple filter paper. Instead of that, we need to use a type of filter paper where the membranes are, the holes are too small. So how to make that one? Let us see it. Ultrafiltration is the process of separating colloidal particles from the solvent and soluble solids present in the colloidal solution by specially prepared filter, which is called as a permeable to which are permeable to all substances except the colloidal particles. Means that all other substances can be passes out through that holes. Only the colloidal particles are not allowed to pass that holes. Then that process of filtration is called as a ultrafiltration. Generally, colloidal particles can pass through a ordinary filter paper because of the large in the pores. However, the pores of the filter paper can be reduced in size by impregnating with colloidal solutions to stop the flow of the colloidal particles. Means that you need to stop the flow of the colloidal particles. For that, you need to dip your simple filter paper to the colloidal solutions. Usually colloidal solutions have, so you need to understand the components of colloidal solution. Usually the colloidal solutions have a 4% of nitrocellulose in a mixture of alcohol and ether. You make a mixture of alcohol and the ether. On that you put 4% of nitrocellulose. Then the solution thus make is called as a colloidal solution. An ultra filter paper may be made or may be prepared by soaking the filter paper in the colloidal solution, and the substance which block the whole of the filter paper can be hardened by formaldehyde and then finally dry it. So you put the filter paper which dip in the colloidal solution to the formaldehyde solution. After then you remove it and dry it. Then you get ultra filter paper. Ultra filtration is a slow process. Ultra filtration is a slow process. To speed up the process, a suction is applied. Means that by applying the pressure and suck it the air, then the process become faster. The colloidal particle left on the ultrafilter paper are then stirred with a fresh dispersion medium. Then you get a pure colloidal solution. So how to get pure colloidal solution by ultrafiltration we have already discussed here. So here in the first line itself we know that how to harden the filter paper soaked in colloidal solution, and then how the process become speed up we have already discussed. Now we'll go to the properties of colloidal solutions. Various properties exhibited by the colloidal solution, and they are as number 1, colligative properties. Colloidal particles being bigger aggregates, and the number of the particle in the colloidal solution is comparatively small as compared to true solution. Hence, the values of colligative property, that is osmotic pressure, lowering vapor pressure, depression in freezing point, elevation of boiling points, are of small order as compared to the values shown by the true solution at the same concentration. So the values of colligative properties are differ as compared to the colloidal solution and a true solution, which we have discussed now. Now next is Tyndall effect. If a heterogeneous solution placed in the dark is observed in the directions of light, it appears clear, and if it is observed from the direction at right angle to the direction of the light beam, then it appears perfectly dark. So colloidal solutions view in the same way may also appear reasonably clear or translucent by the transmitted light, but they show a mild to strong opalescence when viewed at right angle to the passage of light. The part of the beam is illuminated by the bluish light. The effect was first observed by Faraday and later studied in details by Tyndall, and it is called as a Tyndall effect. So Tyndall effect means scattering of light by the colloidal particles, that we call as a Tyndall effect. The Tyndall effect is due to the fact that colloidal particles scatter light in all directions in space. This scattering of light illuminated the part of the beam in the colloidal dispersion. Tyndall effect can be observed during the projection of pictures in the cinema hall due to the scattering of light by dust and smoke's presence there. So Tyndall effect is observed only when the following two conditions are satisfied, means that in order to get your in order to observe your Tyndall effect, you need to satisfy the following conditions. First one is the diameter of the dispersion particle is not much smaller than the wavelength of the light used. Number two is the refractive indexes of the dispersed phase and dispersion medium differ greatly in magnitude. So Tyndall effect is used to distinguish between the colloidal solution and true solutions. Now we will see about the color. The color of the colloidal solutions depends on the wavelength of light scattered by the dispersed particle. The wavelength of light further depends on the size and nature of the particles. The color of colloidal solution also changes with the manner in which the observer receives the light. So the color of the colloidal solution depends on the manner, depends on the way how the observer receives the light. For example, a mixture of milk and water appear blue when the viewers view the reflected light and red when the viewers view by transmitted light. Finest gold sol is red in color as the size of the particle increase. It appears purple and then blue and finally golden. This is what, from this example, we know that the color of the sol depends on the way how the observer receives the light. Now let us go to the Brownian movement. A colloidal solutions are viewed under the powerful microscope. The colloidal particles appear to be in a state of continuous zigzag motion all over the field. Thus, this state of continuous zigzag motion all over the field of the view is called as a Brownian movement. So we can say that the zigzag motion of a colloidal particle is called as a Brownian movement. This motion is independent of the nature of the colloid but depends on the size of the particle and viscosity of the solution. Smaller is the size, the larger is the viscosity, and faster is the motion. So we know that the Brownian motion is independent of nature of the colloids, but Brownian motion depends on the size of the particle and the viscosity of the solution. If the size of the particle is smaller, then the viscosity would be always less, and thereby the motion of the colloids become faster. Brownian movement can be explained or has been explained to be due to the unbalanced bombardment of the particle by the molecule of the dispersion medium. So here Brownian movement of a colloid is because of the unbalanced bombardment, or means unbalanced collision of the particle by the molecules of the medium. So the Brownian movement has a steering effect and which does not permit the particle to settle. So due to Brownian movement, the stability of the colloid is due to the Brownian movement, we can say. So this question was ordered in the board examination. Why or which factor responds the stability of the colloids? So your answer is Brownian movement. Now let us go to the charge on the colloidal particle. Colloidal particle always carry an electrical charge. The nature of this charge is the same on the particle in a given colloidal solutions and may be either positive or negative. So we have here some positive charge salt and some negative charge salt in your table. Now let us see hydrated metallic oxides are of positive charge. Basic dye stuffs, this is also positive charge. Hemoglobin is also positive charge. Titanium oxide is also positive charge salt. Among the negative charge, copper, silver and gold salts carry negative charge. Metallic sulfides are of negative charge. Acid dyestuffs are of negative charge. The salt of stars, gum, gelatin, charcoal and clay is of negative charge. The presence of equal and similar charges on the colloidal particle is largely responsible in providing the stability of the colloid. So the stability of the colloid is because of the charge carried by the colloidal particles. Say, if, as we have already discussed, that colloidal particles have same charges. So same charge, among the same charge there is a repulsive force. This repulsive force prevent the aggregation of the particles, thereby they become stable. The charge on the salt particle is due to the one or more reason. Number one, due to the electron captured by the salt particles during the electron dispersion of the metal. Number two, due to preferential absorption on ion from solution, or due to the formation of electrical double layer. So we can say that the charge carried by the colloidal particle is due to three factors. First factor is electron captured by the salt particle during electron dispersion of the metal, and second is due to the preferential absorption of ion from the solution, and the third is formation of electrical double layer. Development of charge on the salt particles by preferential absorption of the ions is described as, that means by preferential absorption theory you can explain as, the salt particle acquire positive or negative charge by preferential absorption of positive or negative ions. When two or more ions are present in the dispersion medium, preferential absorption of the ions common to the colloidal particles usually take place. This can be explained by the following examples. Now, that means in order to form the colloids, if you want metal atom, then metal atom generally carry positive, so it will have a positive charge. Now, if you want anions, then you will have negative charge. So let us see some that examples. So when highly diluted solutions of silver nitrate is added to highly diluted potassium iodide. So here we have taken potassium iodide first. After then, on the potassium iodide you added silver nitrate. Then we get now silver iodide. This silver iodide is found in the form of colloids. So let us see what is the charge. Now first we have potassium iodide. So iodine is there. Iodine carry negative charge in in potassium iodide. Now our colloid is silver iodide. So we added Ag here to get AgI. So here Ag carry positive charge. Due to that, you will have a positive charge. Means that your absorption is about Ag here. Now, if ferric chloride is added to the excess of hot water, a positive charge salt of hydrated ferric oxide is formed due to the absorption of ferric ions. When ferric chloride is added to sodium hydroxide solution, then a negative charge salt is obtained due to the absorption of hydroxide ions. So like this one, what we absorb, that based on that we get the charge. Now let us see how these charges come this and that based on the another theory. Having acquired a positive or negative charge by selective absorption on the surface of the colloidal particle, this layer attracts counter ions from the medium, forming a second layer. So in case of AgI, we have I minus K plus is there in case of potassium iodide, as I have already discussed. Now you need to get AgI, so for that we absorb Ag, so Ag means having positive charge, thereby you will get positive charge. Now here also again, if AgI is there in the solution, means that Ag plus is there, I minus is there. The combination of two layers of opposite charge around the colloidal particle is called as a Helmholtz electrical double layer. According to the modern view, the first layer of ions is firmly held and is called as a fixed layer, and the second layer is mobile and called as a diffuse layer. So we have, according to Helmholtz electrical double layer, in a colloidal solution we have two types of layer. One is we call as a fixed layer, another one is called as a diffuse layer. Now since the separation of the charges is a shift of potential, the charges of opposite sign on the fixed and diffuse part of the double layer results the difference of the potential difference between these two layers in the same manner as potential difference is developed in the capacitor. This potential difference between the fixed layer and diffuse layer of opposite charge is called as a electrokinetic potential or zeta potential. This what do you mean by zeta potential was in the board examination. Your answer is the potential difference between the fixed layer and diffuse layer is called as a zeta potential. So for today, up to this only we will discuss.